which is basically replicating the game 2048 using DOM manipulation and event listeners and just using vanilla JavaScript. This is the Git repo. The stub is provided. Honestly, I've provided the stub from the solutions because the focus is not on CSS, the stylings, or the HTML itself. It's rather just how we can use JS. And yeah, these are all the details. I've taken the liberty to open up 2048 here so we can demonstrate how it should behave. So if you move left, all blocks get shifted to the left. If you move right, all blocks get shifted to the right. And because there's two 2s in the same row that are not obstructed, if I move right, they should combine and be 4. Yep. And so if we move down, same thing, move up, same thing. And we notice that every time we move, if there's a spare space, it will generate a tile of either 2 or 4 in a random location. And our goal is to just get 2048. I think if I keep spamming it, it will give me a game loss. There we go. So the game loss conditions include when there's essentially no more space to add a new tile. And winning conditions is reaching 2048. Cool. So let's get started. So this is currently what we have. If I open up our code, this is our HTML file. Again, it's just our normal boilerplate, doc type HTML, HTML language N with our head and all our meta tags, and link to our style sheet, which is our CSS. All this is provided. I'll take note of these. We'll come back to this later. But essentially, our body tag will include div, which is our background, a board, then each column. Yeah, it's better structured than most. But yeah, so each div, each second layer div represents a column inside the 2048 row, and each primary layer div is an empty tile. So this is our initial board, and to end with the script for our that will run our game. Looking at our CSS, this is just normal styles just to make it look nice. The things that we want to really take note of are these ones starting from line 71 onwards. So line 71 onwards, it's just empty. And then moving down is style 2, style 4, 8, 16, 32, 64, 128, 256, 512, 1024, and then finally 2048. So essentially, if we are messing with the class names, then we will be using these classes, style 2048, etc., to be manipulating how it gets shown. Cool. So let's get started. So to start off with, we want to, well, our board is going to be size 4, but if we ever want to expand it, let's just add a variable, a constant variable that just defines it. So we don't have to keep writing 4 all over again. Instead, yep, exactly. So much like in C, we will have defined variables that we would just use. In this case, being size and tile empty class. And as we can see, tile empty class just has the string tile empty, which lines up with this line 71 and line 54. So it will apply both these styles. Cool. And in our in our Git repo, says the following function can be used to generate random number, const get random int. This is using arrow notation for function, arrow function notation. It just returns a random number between 2 and 4. Cool. So, cool, let's get started. So first things first, the main functionality of the game is essentially if we press our arrow keys up, down, left, and right, we will move the tiles. So firstly, when we move the tiles and add an event listener, if we add it to say, okay, let's have a look. So say if we turn this off, oops, where is it? Cool. So if I add an event listener to the background div, that means that I have to focus into the div before I can start, before I can start actually messing with the tiles. Let me demonstrate that quickly. So the ID is background, right? So get element by ID, background. Also, let me turn this off. Dot add event listener. Down. Let's just have it say hello. Cool. And I'm going to refresh this, open up console, and I haven't clicked anything, meaning that I haven't focused on anything. And then if I press, if I just click on the page and mash my arrow keys, nothing happens. But if I click on backgrounds, like the top area, nothing happens still. What's happening? Let's key down. Does this exercise include the 204 animations, or it's just instant? In this instance, it will just be instant. Unfortunately, I have to do one of these. By ID background. We just lost. Add event listener, key down, event, console log. Oh well. The point is, we want to add it to the window because the window is always focused regardless. So we can just, anything we do will essentially propagate to window. And hopefully this works. And yep, if I press, we can see that it outputs in console. I actually don't know why it wasn't doing it for background. I should actually have a look as to why that is. Okay, no matter. The point is, we want to, window will essentially log all events without having the user focused on that specific element beforehand. Cool. So do you guys have any suggestions as to how we can structure, as to how we can like, actually, no, before we get to that, let's think through the logic, like the steps in how the game will run. So in the normal 204 game, if we go about here, I'm going to move left. We want to start with generating random tiles to begin with. Yep, that will be the first tile. But in terms of like when a user inputs an arrow direction, like what steps will the logic have to go through in order to like, determine if it's a winning move, a losing move, if it's valid or not, essentially. So if I click left, everything will move, right? So our first thing will be clicking left with an input, means that all the tiles will move, or all the tiles will not move in the case of, okay. In this case, if I press left, all the tiles will not move. So there's an instance, there's steps, input. So on input, we want to check if the tiles have changed state, moved or not. Cool. And if they've moved, then any behavior that is to do with moving directly, such as if I move to the right, if I move down, the twos merge, right? And so that would be one of the behaviors. So we would have to, we'll just deal with that in our internal logic later on. Cool. So we also notice that every time we make a move on the board, a new tile gets generated, right? So we will have to also, if tiles have changed states, we will add a new tile. Value between 2 and 4. Cool. And then I'm just going to spam it till we get to an end state. Actually, I don't even know if this is necessary, but cool. So once we get to an end state, essentially, once we make moves, as long as there is still a valid, merge, even if all the tiles have been completely occupied, that doesn't count as a endgame state. But it's kind of hard to see in this example. But in this example, there are no adjacent tiles that are the same. Therefore, meaning that there are no possible moves, meaning that we have lost the game. So we have to have a game loss check. All the logic to do with checking if any adjacent tiles have the same value, we can move into that game loss check. So we don't have to deal with we can just abstract it into a game loss function for now and just check it if it wins or not. So 3, check if the game is lost. Cool. So if there's a check for if the game is lost, then that means that there must also be a check for if the game is won. And very luckily, the check for if the game is won is just if there is a 2048 tile. Again, we can move that logic of actually checking if there's a 2048 tile into the function that we'll use. Instead, let's just say check if the game is won. Cool. So this is the sequence of events that will happen every time we move. We move the board around. Does this look? How does this look to you guys? Anything we need to change or anything like that? What do you mean by the first step? So, sorry, the first step. Do we move it ourselves? Okay, so what I mean by the first step is after user input, which is like the arrow keys, what we want our code to do is check if the board itself has actually changed. So there are some instances when even if we do an input, the board will not change. Again, I will try to find an example. So in this example, if I press the right arrow key, the board will not change, and therefore nothing will happen because the board doesn't change, right? So a new tile doesn't get generated. I'm spamming, you can't see it, but I'm spamming the right arrow key. So nothing happens. So that's what I mean by the first step, meaning that we want to essentially check if the tiles have changed state. Because if the tiles have changed state, that means that we can therefore add a new tile, merge tiles, move them around, etc. Cool. There's actually one small change that is necessary, and that is the ordering of the step in which we want to check if the game is won or not. And the reason why that is because when do we check if a game is won? What about in the instance where, so stop before what? Not necessarily, because in our logic of like moving the tiles itself, we can, I guess, make our code more lightweight by having the logic of moving the tiles around return if the tiles have been moved or not. So no, you could implement it in such a way that you have a previous state and then an after state, and then you compare the two. But in that case, you get into some issues of like space. It's just like slightly larger. It's like negligible, but the way we will do it is we'll check if the tiles have moves by having the logic that moves the tiles return a Boolean that states if it's moved or not. But what I was going to say was, with this series of steps, there's a particular case in which this will fail. Like there's a particular case in which we win, we are supposed to win, but we actually lose. And that's the case when after we move, we get a 2048, but every other tile is occupied and there is no way for us to move the tiles around anymore. So an example of that would be, oh man, okay, an example of that would be, let's see, 2 4 2 4 4 2 4 2 2 4 2 2 4 4 8. So this is after our last move. Oh no, sorry. 2 4 2 4. Yeah, 4. Cool. So that's a 4x4. We can see that there are no, all adjacent tiles are not equal, meaning that we can't make moves. However, there is a 2048, meaning that we should win. However, if we follow the steps, so this is currently, so this would be the board state after step 2. So this is the board state after step 2. So we should check if it's, sorry, and then we check if it's lost. When it's lost, therefore, there's actually no way to get to winning if that's the case. And Jimmy, you are correct. We should check if we've won first. Exactly. So where should we put the win check? Where instead should we put the win check? Before which other step? Yep, we can do checking before it's lost. We can also do checking, we can also do it before we add the tile, because either of these is fine. I think doing it before makes a bit more sense, because after you've won the game, there's really no more progression on the board. But this is just going into semantics of like how the game should operate. Either putting it in second or putting it third is fine. It doesn't really matter. So, but I will put it as second. So this is our sequence of events. So essentially, we will try to like emulate these steps in our event listener, because these are the steps that we'll have to take upon every input. Cool. So I'm going to assume that you guys have already gone through and like looked at the event object in JavaScript and event listers and everything like that. So I will briefly skim over it, but won't go too in depth. Cool. So this is our first step. And then we want to check if the tiles have moved state. And I said we'd do this by having it return a Boolean that would tell if it has returned a state on if it has moved or not. So let's let a variable called moved be equal to false for now. And then we can do a whole bunch of things. We could either do an if-else chain or a switch. I think switch is less intensive, but in this instance, it doesn't really matter too much. But what's essentially happening is what I want to do with this if-else chain or switch statement is I want to check if the key that I'm getting, that the key that is getting pressed corresponds to a certain other key on the keyboard. And if it matches, say with arrow up, then we will do the move up. We would execute the move up function, and then all the logic from that will follow. So if I was to do it in an if-else chain, then it would be if events.key. You can see that there's a key code, but it's deprecated. So we do key, and it's a string, and that's equal to arrow up. Then we will do moved is equal to, we actually don't have this function yet, so let me write stubs. Will be equal to move up. And so that's with an if. If I was to do it in a switch, which is variable, we would just do event key, and the switch statement essentially checks if the case, and then you provide the case, is equal to, sorry, if the event key is equal to a specific case, then we'll execute the code underneath each case. So in the case arrow up, we will do moved is equal to move up, and then we want to break it because switch statements are kind of messy in that if you don't include a break statement, it will just continue to propagate down. So if I did not have this, then if I press the arrow up, then if I press the arrow up, then it would propagate down to arrow down, and it would also execute a move down. So I want to include outbreaks. So bear with me. One minor nitpick is we would also add just for like correct code, it would add a default, which essentially is when when our event key does not match any of the previously stated cases. So if I press the key A, for example, then it will go, because it doesn't fit arrow up, arrow down, arrow left, or arrow right, it will go to default and then we'll execute the code at default. I'm just going to do a console log. It's also fine if you don't include anything in your default, because but it's just better code to include something there to inform us that the switch statement has encountered like a value for its parameter that is outside of its defined bounds. And we don't need a break because it's at the end and it doesn't propagate down anymore. Cool. So that's step one. And step two, we want to check if the game is won. That also means that we want to have a game one check. I'll move it above our move ups because it's quite easy to implement. So if check game one check. If game one, then we let's just do console log v1. We can mess with DOM stuff later, but that is not really the point of the exercise, so we can just ignore it. And cool. So our step three is if the tiles have changed state, we will add a new tile with a value between 2 and 4. Easy, lazy way to do an alert, it's true. I actually have not used alerts, but you can use an alert. Also, for your assignment 2 and assignment 3, it's not advised to use an alert for any modals that you want to do. But yes, in this instance, you can use an alert. You could also use a console log, because in this case, we don't really care about it. Cool. Step 3, if the tiles have changed state, we'll add a new tile. So in that case, because we have a variable called moved that tells us if the variables have changed state, then we can just use that. So if moved is equal to true, then what we'll do is we will add a random tile, which will use this get random int, but we have not had that one. Don't have that stub function yet, so I'll set that. And random tile. Cool. You guys might have noticed in JavaScript, because it's not a strictly typed language, we can mess around with a whole bunch of things. For example, I think you guys might probably encounter this in 1511 early on, but instead of doing moved is equal to true, because moved is a boolean, you can literally just do this. But there's a concept called like truthies and falsies, in which certain JavaScript variables are mapped to true or false. Say, for instance, a value of 0 would be mapped to false, a value of 1 would be mapped to true, as an example. And additionally, null is false, and undefined is also false. Most other things would be true. But that's just a tangent that we won't deal with for now. Cool. So that's step 3. And step 4, very similar to game 1 check. We will just add a game lose check, game lost check, alert, lost. Right, so that should be our event listener. Let us go through and add the checks for these game ones. So our game one check is literally checking if a 2048 exists, and that's literally it. Because we will be checking if tiles, because we will be dynamically applying styles using JavaScript, what we can do is we can literally just check if there are any tiles with this particular class name in our DOM. And if such a tile exists, then we've won. Hacky way, and it doesn't really require us to like go through the n squared check of like checking if there's a 2048 if we were to use a state instead. Actually, no, I think it like kind of does the same thing, but it's just like it's on the browser. You just like the browser does the checking for you. So document dot, much like get element by ID, there's also get elements by class name. There's get elements by name, which checks the name attribute. There's also a tag name, which is like the HTML tag, I believe. And there's, I think that those are about it, but those are the ones that you should be using. There's also query selector, but we won't be using that for now because what we want to do is we want to check by class name. So check by class name, style 2048. This returns an array. Well, a list, a collection of. So it's a list. So if this is greater than 0, then we've won, right? There's no need to check if it's like strictly equal to 1, because if the person chooses to continue playing, then the number of 2048s may or may not be greater than 1. So we just check if it's greater than 0, and we just return this. Cool. So we want to also do our losing conditions, and in this case, so how we check if our game is lost is if there are no empty tiles, and if adjacent tiles do not have the same values. And if all adjacent tiles do not have the same values. Cool. So if there are no empty tiles, I think, okay, if there are no empty tiles, we can also kind of just merge that into the check if adjacent tiles do not have the same values, because wait, sorry. No, never mind. Let's just keep it 2 separate checks for now. And to do our check, this would be another instance where you would use like a board state object list of arrays inside your JS, but we can also just use browser DOM manipulation arrays and lists and stuff like that to do the job for us. So const columns would be us grabbing all of our columns. And luckily we have defined it pretty easily for us. And that is simply documents dot get elements by class name, and that would be board column. So this would return to us a list of columns, and inside those columns there would be a particular property that we would be able to use to get each individual tile. So because we're checking adjacency, we need to have an n by n, n by n matrix kind of thing, doubly nested for loop that ib0 is less than size I++. Or that j0 size j++. So let's check left to right first. That's pretty straightforward. If columns I, so this is for each column, and we want to check each individual child. What we can do is there is a particular, is there one? Child. Okay, I don't know why it wasn't appearing in the thing, but I think it's just like it's too far down because there's a lot of, there's a lot of attributes. But there's children, which gives us a, again, very similar to what columns is. Children is essentially a HTML collection of child elements. And because those child elements can also have child elements, that's why it's like not an actual HTML element node kind of thing. But in this case, our child is literally just only has one layer, so we don't need to worry about that. We'll just do j dot inner text. Cool. So how we check adjacency is we check if the inner text of each tile is the same as the next one, because we will be adjusting the inner text on the fly as user does their inputs. So there's no real need to so that's probably the easiest way to go about doing it. So we just do inner text. It suggests inner HTML, but in this case, I think inner text is fine. Double equal to columns I dot children j plus 1 because we're checking adjacency text. Then we want to return false. So this is the check. Sorry, the check that we've just written is if two adjacent tiles have the same value. If they have the same value, then that means we haven't lost the game yet, right? So therefore we return, we exit the function with false, that our game has not been lost and that we can continue. And additionally, this is for each column. And we also want to do the same for each row. So very similar, but we just swap the i's and j's around. Except this would be as this one. Cool. And even after all this, and there hasn't been any return falses, then we will return true, or the game has lost. I'm also going to do a check for no empty tiles. We'll do that by doing let empty tiles be 0. And if columns I columns, sorry, not columns, children j, so in a text, it's equal to an empty string, then we would add empty tiles. And finally, if empty tiles is I was going to say return empty Boolean empty tiles, but that wouldn't make sense because that would change our return type. And I'm just going to do a check. So if empty tiles is equal to, sorry, no, if it's greater than 0, then we return false. All other instances, we return true. Cool. Adding a random tile. Okay, So in the interest of time, I'm just going to grab this and put this in. So I'm going to run through the code. Empty cell list essentially grabs us a list of cells that are currently empty, and that is just by, same thing as before. Any empty tiles will have the empty class attached to them, and so this will return to us whole list. And then a random cell essentially grabs a random empty tile using the getRandomInt helper function that we were provided, and then inside that random cell we would assign a random value. We would be assigned a random value based on if randomInt is 0 or 1. And then we would assign the random cell's inner text to be the random value. So that would be either 2 or 4, and give the class name, tile, and then the style with the associated random value. We could do class name. Class name essentially overrides the previous elements class entirely and replaces it with this. This is like, these are two different classes, but if you just have one class and you do element.className is equal to another thing, then that previous class gets erased. You can do class list, and then there are methods inside that class list. Class list object that allows you to just add or remove classes. But in this case, overriding is fine because we have tile and then we want to do style. And also in further instances, there are examples when we actually don't know what the value is from a general standpoint. So it's better to just override it in our case. Cool. Another thing I forgot to do is we actually haven't initialized the game. So we just have a setup function. What it does is it just sets the top left tile to be 2. Const tile equals to document.get. Nice. Class name. 0. The first one dot children. And then the first one, so this is the top left tile, and then tile dot inner text is equal to 2, and tile dot last name is equal to tile style 2. Cool. And then we would call this setup function at the end of everything when we've defined everything. And because it executes top to bottom, when it reaches code that isn't defined, when it reaches the very end, it should execute the setup function, and then we will be good to go. Cool. So that was all the setup required for this. So let's actually go about at least trying to implement I'll implement one of the move up functions. And then because essentially it's we can just adapt the move up function and just make minor changes and apply it to down, left, and right. Shouldn't be too long, but move up is slightly complicated. So moving up consists of, so there's a few ways we can do move up. Essentially, what happens when a tile is moved is everything is shifted over to whichever direction we define. So if I do down, before I do down, when I press down, what's going to happen is all the tiles are going to shift down, but additionally, any adjacent tiles that are shifted down that are all piled up at the bottom, any adjacent ones that have the same value will be added together, right? So that means, they'll all be added together, and then once any of those values that add together, anything in the okay, it's hard to explain, but once everything is squashed together, everything will still be compressed in the direction that you desire. Meaning that if I press down here, and there was a value that was a 2 to like in this, it's really hard to explain, but like, okay, cool. So ignore that I did another move, but after I merged the two twos together, assuming there was this existing 2 above the other two twos, this would be what would occur if I had merged everything and then but had not then proceeded to compress everything further down. So this should be our end state if there were 3 twos in the right column. So what that means is there's a few ways we can go about doing this. One way is we could just compress everything in one go and then do a loop, a recursive loop to make sure that everything is compressed. There are no empty tiles between the bottommost layer. That is quite complicated, I would say. But there's another way we could do this is we could have 3 discrete steps. One involves the actual sliding, moving everything. The second one involves merging, merging the tiles together. And the third one involves sliding everything again. And we can structure our logic in our merging code such that any of the any adjacent tiles will be squished together, and then there won't be really any guarantee of sorry if there's okay, in this example, so say this is one column, right? So say there's the example of this. So this is one of the columns. Once I press down, what's going to happen in the first step is, well, okay, slide. Then nothing will happen because there's no empty space for it to slide. And then our next step is merge. And what we will do is we will go from bottom up. So that means that our first step would be 2, 2, and then 0, 4. And then the next sub step in that merge step would be 0, 4, 0, 4. And our last discrete step would be slide again. And so our final state would be 0, 0, 4, 4. So your question might be, why is it that if there's multiple, if there's 2 4s top to bottom and we press down, why doesn't it all compress to 8? And that's because, unfortunately, that's just how the game works. There's only, you only merge between immediate adjacent ones, and it just goes in one particular direction. And this bears through in the game. I don't even know if I'll be able to get a state in which I can demonstrate something like this. It'd be really difficult to get an instance where that occurs. Okay. Okay, cool. So as we can see, the rightmost column is very similar to our example before. And so if I press down, I expect it should be 0088. Yeah, 0088. So that's just how the game works, unfortunately. So luckily for us, that makes things a bit easier. So let us divide it into 3 discrete steps: a slide, a merge, and another slide. So that means that move up will have 3 steps to it. Slide up. Okay, we got there. Cool. So what's happening here? So moved is essentially what's going to be our variable for determining if the tile state has actually changed. However, there's something wrong with this in that there's some instances where, so in this example, if we slide up and things move, then it gets set to true because slide up will also be a Boolean, will return a Boolean, so we'll merge up. So moved is set to true. And then if we do merge up, that will, but there's like no merges that go on because the tiles that have been slid up and not moved and not merged, sorry. Therefore the tiles have not moved. Therefore, moved from the perspective of merge up will be false. And so will slide up because there are no spaces for the slide to occur. So what this will actually return is false. And that's not correct, right? Because the tiles have actually moved, meaning that there's something that we need to change with this code. Actually, it shouldn't. Okay, it's okay if you don't wrap your head around this to begin with, but what we'll do is we'll just add bitwise OR operations. What this vertical line, like this bar equals operator, is essentially the same as it's the same as this moved is equal to moved merge up. It's essentially the same as this. So it's either moved as it was previously, or the value from merge up. And how OR works is if it's true and true, then it's true. True and false, then it's true. False and true, then it's true. Only if it's false and false will it be false. So cool. So what this does is if it's slid up, then it's true. But if it doesn't merge, then moved will continue to be true because true or false, therefore true. And therefore, because it did not merge, it will not slide again. But moved will remain true because it's true or false, therefore true. And therefore, we will return moved is equal to true, indicating that we have actually moved the thing. Does that make sense to everyone? Cool. In the interest of time, I will add these helper functions. Again, these might seem a bit complicated, but what they are essentially doing, I'll go through the top one because left to right is essentially the same. Up, down, column loop, what it does is this callback is what we will, okay, it looks complicated, but what this is essentially doing is it is making our code easier to read in that there won't be like hella nested code or like hella indented code. So what's essentially happening is this is just the setup for a loop once again. So const column list, again, a list of columns, and then for I to size, so from 0 to 3, we will execute a piece of code on each column that will determine if we have moved or not. And we'll use up down call in our in our slide up and slide down kind of thing. And if it has, if this returns true, then we set our move to true and then we return moved. If it returns to false, then moved doesn't get set to true, meaning that it remains as its default false, and we will return false, meaning that it has not moved. Same thing for left to right. Also, I noticed that it's getting close to 7 p.m. So if you guys have to go at 7, that's okay. I'll just finish this question so that you guys can review it afterwards when the recording gets uploaded. Cool. So let's start with slide up. Again, let moved is equal to false. what we will do is, so let empty equal 0 and 4. Let j is equal to 0. J is less than size j plus plus. What I want to do here is so cool. So what empty means is empty is the index of the cell which we will check if is empty or not. So essentially empty, what empty should be is the index of the currently empty cell, starting from 0 and iterating to like 4. So in fact, this is not really correct. Of the hopefully next empty cell. And why that is important is because these empty cells, we want to keep a counter of which cell is empty so that when we make our move, we can occupy that empty cell with the properties of one of the non-empty cells, if they're assuming that there is a non-empty cell. So we will do the check if empty cell is actually empty or not. And if it is not empty, then we will just iterate the empty counter. And j is just our normal iterator. And it does not, it just iterates through. Nothing really much else to say about j. So cool. In our for loop for j, so firstly, what we want to do is we want to check if, sorry, I forgot some things, but what we want to do for in our loop is we want to check if the currently indicated empty cell is empty or not. If it's non-empty, then we will iterate the empty counter, right? And afterwards, then we'll do an else if, and then we'll check if the cell as indicated by the j, if that is empty or not, then we will do some swap magic, and then the currently empty cell will inherit the properties, sorry, not inherit, will swap the properties with the cell of j, and then empty will iterate because the empty cell that we swapped with is no longer empty, and that's essentially it. I will write it up in a bit. Feel free to like pore over it to like further understand it. It's a bit difficult to understand it first. Also, it's 7 p.m, so feel free to leave if you do need to. I forgot that we don't actually understand what column is. That's because I forgot to put in the helper function that we were doing. So what this does is, so what we will do is we will return up, down, call loop. And inside that up, down, column loop, it would be, we'll pass it call I. These call and I values are the values inside here. Sorry, no. Yes, wait, no. These, what is essentially passed inside here is the callback that we are passing to the helper function. Yeah. All dot children empty dot class name is not equal to, previously we defined a constant value for tile empty class. So we want to check if it's empty or not. So we will just check if it's tile empty class. If it is, then we will add, we will iterate the empty value. Else, if call children j class name is also non-empty, then what we will do is we will swap the values, like I said before. If empty and j are the same thing, as in this instance where, in the instance where like j is equal to 0 and so is empty, then it will still swap, but like it won't really change much. And so empty will iterate again. So call children empty class name. I say closed. And then we swap. Then we assign what was previously j. Assign what was previously j because the properties of j have moved to the empty cell. We assign the properties of j an empty cell, so we just swapped around. So that would be class name to tile empty class, and call children j in a text is equal to empty. Cool. And because in this instance a swap indicates a move, we would set moved is equal to true, and moved doesn't get changed elsewise, and it also iterate emptied. Cool. And cool. So that's slide up. Let's do the same. Let's do something similar for merge up. Let me copy this and we will make adjustments to it. So luckily, this is less, well, this is easier to understand. What we do when we check if the, what we do to merge is we just check if it's non-empty and if the text inside a cell is equal to the text of its adjacent cell. And if they are equal, then we just merge it. And that's really it. So there's nothing really much to it. So for that j is equal to 0, j is less than size -1. Size -1 because we will be accessing j plus 1. And if j plus 1 doesn't exist, then JavaScript will be very unhappy and throw us a rare error. So if call children j dot class name is not equal to empty, sorry. So if it's non-empty and call and text is equal to that dot in a text j plus 1 in a text. Then what we do is we then we multiply the, because it's a merge, merges, even though they're adding together, they only add together when they are the same value, meaning that it's essentially doubled. So we can just double it. That means that all we need to do is we can just access the value of our current column children j and just multiply by 2. What we can't do is we can't do call, we can't do this, because inner text is a string, and this actually I don't think will throw us an error because JavaScript is weird. So what we need to do instead is we need to wrap this in a function that interprets the string inside the J cell as an integer, and we just multiply it by 2. Cool. And then call children J dot last name is now equal to, actually, I should move this out. Because I will be using the same code and I don't want to write the whole thing again. Cool. And then because we did a merge, we did a merge, J is updated, but J plus 1 is now going to be empty. And so that means that that's going to be tile empty class. Oops. It's going to be this is equal to that. Okay. And boobs is equal to true. If that's the case. Otherwise, false. Cool. Because everything else is pretty much the same, I am going to just do these changes. Hopefully, everything works. Cool. I'm not going to rewrite all this, so I'm just gonna grab it. In a slightly more condensed form. This is okay, so we can compare these two in that this has merge up is equal to parentheses is arrow to curly braces and then a return. But this one is just straight arrow to up down call loop. And this is just shorthand for if there's no curly braces, then it's just going to be that return value. Like that value is going to be returned, meaning that this whole thing, the return value from this function is going to be returned as slide down. I just wrote it as return the call loop because it's slightly easier to read. And then same for slide left, same for slide right. Okay. Okay. Okay, cool. I was worried it wasn't working. So I'm pressing left, moves everything over, down, down, right,